Hello, and welcome to this series of videos in support of this Materials Made Smarter outreach demonstration of how computer vision and machine learning can be used to recognize different materials to make recycling easier. My name is Dr. Robert Gibbs, and I have developed this demonstration with Professor Giannetti of Swansea University for Materials Made Smarter. Documentation about the theory behind this demonstration and instructions on how to use this demonstration are available at Discover Materials by scanning the QR code. Also available on the Discover Materials website, an electronic version of the printed booklet and further information about the code, the equipment, and progressively more detailed project documentation. In this first video in the series, I will walk through how to get the system running. I assume that you have set up the equipment hardware according to the written documentation on the website. Okay, as we power on both units together, we have the video connected to the second of the Seeed Studios recomputers. These are based on the Jetson Nano 2GB system from NVIDIA, and they are running Ubuntu 18. We use one of the computers to drive the video display and the web interface, and the other computer, with its own graphics card, its own GPU, is providing the machine learning and the code behind the models that are provided by the NVIDIA DLI course. So we log into the second system with the username Jetson2. The password is JNANO23. That's JNANO23. We're logging into the Ubuntu 18 interface. Neither of the computers is connected to the internet, and that should remain the case so that the system doesn't break itself. But the two machines are communicating to each other over a private Ethernet cable. In the initial interface, there are only two applications that we need to run for this demonstration. First of all, we launch the terminal by double-clicking on it. You can see here that this is the terminal for Jetson 2 at Recomputer 2 on the second unit. So we need to access the first unit, and we do this by typing in SSH, it's a secure shell, into Jetson 1 at 192.168.0.1. This is the IP address for the private network between the two machines. Jetson 2 has an IP address 0.0.2. You don't need to type in this command because it is already in the history, so you just need to press the up arrow to get that command. Press return, and it will ask for the password for Jetson 1, which is the same as that for Jetson 2. JNANO23. JNANO23. It won't display the password, but if you hit return, we are now logged into the Jetson 1 user on Recomputer 1, which is the first unit. This is the unit that will be running the Python code and the Docker environment for the machine learning. Again, the following commands are stored in the history, so you just need to press the up and down arrow, or you can type them in. But if we press up once, we get exit, because that was the last command we do to leave the system. We press up again, and we get this call to a shell script, MMSC BCCC, which is bottle, can, or coffee cup, start. And this is a shell script that's running on the first computer, Recomputer 1. The password again, JNANO23. And give it a bit of time. At the moment, it is launching the Docker environment for the machine learning code that is written in Python. The Docker environment is provided as part of the Deep Learning Institute's course. And you can see here that it has started a Jupyter Lab server, and it provides an IP address to access that server, HTTP, and then 192.168.0.1, the IP address of the first machine, at a port number 8888. And there is a password here, DLI Nano, which is the password for accessing the Docker environment of the DLI machine learning course. We leave that terminal running now. So the first computer is running the Docker environment, and now we need to access that Docker environment using the Jupyter Notebook server. So we double click on Chromium web browser. This launches in full screen. We will be accessing this web address here, which you can click on yourself there, but also this shortcut here, Jupyter server, will take us straight to the Jupyter server. We need to enter the password for the Jupyter server, which is again written here, DLI Nano. So we enter that password, DLI Nano, hit return. And we've logged in to the Jupyter Python environment that is running on the first unit, Recomputer 1, with Recomputer 2 providing the graphics display and this web interface to that headless Python environment. The files here contained in the Docker are those from the DLI course. Our project is found in data, which is an environment that can be accessed outside of the Docker. Inside that folder is another folder called images, which contain 50 of each of the categories of objects. 50 examples of each of the categories of objects. These are our training data set. If we go back one, we can see examples of a can. There are 50 images of a can. This is the training data set that is already stored on the machine. You can see that it is stored in a folder BCCA, and in the next video we'll see how we can create a B or a C, 2 more data sets, if we want to experiment with having our own data sets. But the system comes already with this A data set of 50 images of each of the types of object. Let's just have a look at the coffee cup as well. So in general, the training data set is the picture of the object at many different orientations. The utils.py code and the dataset.py code are libraries that we need in the system. BCC banner is the image at the top of the code, as is experimental setup is the photograph of the equipment that's in the code. The code itself is MMSC BCCC Python notebook. When we open this up, we can see bottle, can or coffee cup, and we have all of the Python code needed to run the system, with the final command being to display the project controls after it has started to run. I will run through this code in the third video of the series, but to get the system up and running and be able to operate the identification, we go to kernel, restart kernel and run all cells. You click on it, give it a bit of time, and then we click on restart. All of the cells will begin to run. It takes a little bit of time for the system to get up and running. And once all the code has been run, the system provides this interface, which has a live view of our object inside the photographic cube. And we will run through how to use this interface in the second series of the video. I'll see you there.